Video lesson 5.4. We're going to talk about the properties of a rhombus. So, like as we discussed prior, again, a rhombus has 8 properties in total. The first set is that it has all the properties of a parallelogram, so that's 5 properties there. And then an additional 3 that make it unique, and specifically what makes it a rhombus versus just being a regular parallelogram. So, but in total, it's got 8 properties. So let's look at this first proof. All right, we'll do a formal proof here. We're asked to prove that I've got two angles congruent, ADE, which would be this one here, and CDE, which is this one here. So we want to prove that these two things are in fact congruent to each other. You've got a variety of ways you can do this. The fact that they give you the diagonal DB and they tell you that it's a rhombus really does make this proof kind of a relatively quick one in comparison to other things that we've seen. But typically, in these types of proofs, you more likely have to actually prove triangles are congruent to then show that the parts are congruent. So, it's kind of a thing here that you can kind of go both ways, but just for purposes of showing an alternate kind of way, we'll talk about it, but we'll see what I mean when we get into it. So let's get ourselves a proof here. So statement reason. So the fact that I'm just looking for these two particular angles, they tell me that ABCD is a rhombus. So they're telling me that this figure here, ABCD, is a rhombus. So right away, I've got all those 8 properties that are there. So the first one is that ABCD is a rhombus, and that's a given. So technically, again, because I know this is a rhombus, I know that diagonals are angle bisectors like they have up here on here. So I could then say that this angle and this angle are congruent, and the resulting angles next to them in here are supplements of supplementary angles. So this proof really is a much quicker than other ones that we've seen because of that. Now, if they didn't have that diagonal there, this would be a little bit more work. You'd have to kind of get a little bit more creative. Typically, these kinds of proofs more commonly are looking for, we would have to find, for example, this triangle here and this triangle here, and then prove that they're congruent, and then that would say that their parts are congruent using CPCTC, which would be specifically this ADE and the CDE ones. But again, in this particular case, we don't have to do that, so we're a little lucky in that case. And this is a much faster and simpler proof. But it's not wrong if you still did that. If you didn't notice this, it's not wrong. But I'm going to call this angle 1 and angle 2. So we can say angle 1 is congruent to angle 2. And my reason is in a rhombus, diagonals bisect the angles. So DB is a diagonal, and it bisects that angle ADC, splitting into 2 equal pieces. So these are equal here. All right. So if those are equal, then I can make the claim that angle 1 plus angle, and I'll use what they named it, ADE, has to equal 180, because these would be supplementary angles, right? And also angle 2 plus angle CDE has to also equal 180. Again, over here, these are supplementary. And my reason is linear pairs form supplementary angles that are congruent. And that allows us to make the claim that angle ADE is congruent to angle CDE, which is what we were asked to prove here. Because supplements of congruent angles are congruent. And we're done. All right, we've actually proven what they've asked us to prove. So again, this is a little, definitely a shorter version of proofs that we've seen with these types of questions. But again, it's if you can find these kinds of things using the properties, a lot of times that's a possibility, and it's great. If it's not available and you had to go through, showing the triangles themselves were congruent and then that their parts are equal using CP/CTC, so be it. And even in this one, if you didn't recognize this right away and you went through that process, it wouldn't be wrong. You'd be perfectly fine being able to do that. Right? Again, it'd be longer, definitely more work involved, but perfectly fine to do. All right, let's look at some of these other types of questions, these algebraic questions with dealing with the properties. So in number 2, we got rhombus ABCD has a diagonal of AC and DB that intersect at E. And I'm told that AB, so I'm told that this line segment here is 5x. I'm told that AD, which is this line segment here, is 3x plus 6. And they want to know what is BC. That's what I'm asked to find. Well, at first glance, maybe this looks like they don't really give me a whole lot. All right, but since we know it's a rhombus, right? Since we know that it's a rhombus, again, we know all of these properties up here. And one of them is that we've got all 4 sides are congruent. So AB and DC and BC and DC, they're all congruent to each other. So if I find out what X is, I can just figure out what any one of these sides is, and then BC would be equal to that. So in this particular example, I can say that AB is equal to AD, which is 5x is equal to 3x plus 6. This allows me to solve. So I can say minus the 3x here. We've got 2x is equal to 6. Divide both sides by 2. And x is equal to 3. Once again, that's not what I've asked to prove or find. In this case, I'm asked to find BC. So I actually got to plug it in. Again, it doesn't matter who in this case, right? Because AB is equal to AD, which is equal to BC, which is also equal to DC. But it doesn't matter which one we use. Just pick one of them. All right, so BC is going to equal, I'm going to choose 5x because that's a nice simple one. So 5 times 3 would give me 15 for my answer. And again, if you checked, you could plug it into the other one. 3 times 3 is 9, plus 6 is also 15. So again, it doesn't matter which version of the sides you use. They all should be the same. All right, so again, utilizing the properties, being able to identify the information and set up the equation is what makes these questions possible. The other thing, again, just as we've kind of mentioned in previous videos, identifying the types of triangles that are inside of the figure will a lot of times help me be able to answer questions quickly or with more ease and things like that. So identifying here triangle ABC, that's this one here in this picture. ABC, if you notice, right, AB and BC are the sides of my rhombus that they tell me. So that means these two sides are equal. So that makes this an isosceles triangle. And DEC, which is, excuse me, here, it's this one, right? I don't have any of the sides being congruent because the diagonals, they bisect each other, but they're not congruent in length. I've only got one side of the rhombus here in this triangle, so I don't have anything there. However, if you go back up here at their properties, you remember and you notice that diagonals are perpendicular to each other. So if you come back down here, that would mean that this angle right here at E in that triangle is a right angle. So that makes this a right triangle. And again, I've got multiple, right? All of these. DEC, which we just found. BEC is also a right triangle. BEA is a right triangle. DEA is a right triangle. Those are all right triangles in this picture. Right? And similarly, with the isosceles, we've got a big isosceles triangle up here that we've already discovered, ABC. I've got another one down here with ADC. So you got more than one thing happening, but just being able to identify the types of triangles you have will make your life easier when trying to solve things, especially if you're looking for angle measures and stuff like that. Because again, in this type of a question, they can just simply give you one, right? If I gave you like this angle right here was, let's just say this one is 40, right? You can then go and find everything else, right? Well, if this is 40, right? This is 90, right? Because it's perpendicular. So that means this one over here has to be 50 because they have to all add up to 180. And then again, this big purple triangle is isosceles. So this would be a base angle, which would be congruent to this one. So this one's also 40. This is also a right angle, which means this one's also 50, right? Opposite angles are congruent and the diagonals bisect each other. So if this big angle up here is 100, aka 50 and 50, then this big angle down here has to be the same thing, right? Again, these would have to be 40 each also, and this one's 90. So again, just by giving you one angle, we were able to figure out all of them because we know the type of triangles that are being represented inside of this figure. So again, that's the kind of thing that helps out being able to make your life easier and be able to solve questions like this with more ease. Again, all knowing the properties, all coming out of these properties that we have here. All right, so take a chance. Again, pause the video, rewind the video, watch it over, whatever you need to do. Make sure you take good notes and review anything that you're still having trouble with.